Python nerds. I'm Jared, and you are listening to The Changelog, where each and every week we sit down with the hackers, the leaders, and the innovators of the software world to pick their brain, to learn from their mistakes, to get inspired by their accomplishments, and to have a lot of fun along the way. On this episode, I'm joined by the co-hosts of the Core.py podcast, Pablo Galindo and Łukasz Longa, whose name I will pronounce Lucas from here on out because it's just a lot easier for me. On Core.py, they talk about Python internals because they work on Python internals. And today we're talking about Python 3.13, which is right around the corner. When we recorded this conversation last week, it was slated to be released on October 1st. But now they are targeting October 7th. So if you're listening to this in the future, 3.13 is fully baked. But if you are listening right after we hit publish, wait a week or grab the release candidate, which is 99% baked. Why are we also excited about Python 3.13? Well, the global interpreter lock, aka the GIL, is now experimentally optional. This is a huge deal, as Python is finally free-threaded and able to run with true parallelism. There's more, of course, and we get into all the details. I think you'll enjoy it, even if, like me, you aren't a regular Pythonista. But first, a mention of our partners at Fly.io. Over 3 million apps have launched on Fly, including ours. And you can too, in less than 5 minutes, learn how at Fly.io. Okay, free-threaded Python on the changelog. Let's do this.
Hey friends, I'm here with Dave Rosenthal, CTO of Sentry. So Dave, I know lots of developers know about Sentry, know about the platform, because hey, we use Sentry and we love Sentry. And I know tracing is one of the next big frontiers for Sentry. Why add tracing to the platform? Why tracing and why now?
When we first launched the ability to collect tracing data, we were really emphasizing the performance aspect of that, the kind of application performance monitoring aspect, because you have these things that are spans that measure how long something takes. And so the natural thing is to try to graph their durations and think about their durations and, warn somebody if the durations are getting too long. But what we've realized is that the performance stuff ends up being just a bunch of gauges to look at, and it's not super actionable. Sentry is all about this notion of debuggability and actually making it easier to fix the problem, not just sort of giving you more gauges. A lot of what we're trying to do now is focus a little bit less on the sort of just the performance monitoring side of things and turn tracing into a tool that actually aids the debuggability of problems.
I love it. Okay, so they mean it when they say code breaks, fix it faster with Sentry. More than 100,000 growing teams use Sentry to find problems fast, and you can too. Learn more at Sentry.io. That's Sentry.io. And use our code CHANGELOG. Get $100 off the team plan. That's almost 4 months free for you to try out Sentry. Once again, Sentry.io.
Today I'm joined by Pablo Galindo and Łukasz Longa from Core.py, a podcast all about Python internals because these two work on Python internals. Welcome to the show, guys.
Thank you very much for having us.
Happy to be here.
Now, your podcast, is it usually just the two of you talking to each other, or do you have a third party ever?
Every now and again, we would invite a guest, but mostly it's just the two of us.
Yeah, when people are fed up of listening to us, and then we bring someone. So.
Now, we've been asked to start a Python podcast a few times, as well as an Elixir podcast and a Rust podcast, and we don't usually feel like we have anything to add to the conversation, except when it came to Python. I remember telling our friend Brett Cannon, I said, you guys should have a podcast where it's like the people who work on Python talking about Python, not randos like I would be, or the people on the, it's a huge community, but There's no voice that is like coming from the core team. And so I think it's pretty cool. When did you guys start this and what was the big idea?
So we started actually 1 year ago. Right now we are in the core developer sprint at Meta. So this is basically a meeting that we do every single year when we try to bring all the core developers together and spark some conversation in person, because open source is basically based on asynchronous communication, but from time to time it's very good to not having to discuss and wait like an entire day just to tell the other person, I don't like your your proposal. So we after that, these meetings have a lot of discussions, and they are super rich regarding that. Like it's fantastic. Like it's one of my favorite moments of the year. And so I reached to Gukesh and I say, hey, it would be actually very cool if, because like what happens here, like people don't really know the discussions, they just know the output of them. And like there is many of these projects that take years, or like they only show after a time. And there are some of these projects that just die and they never happen. And I was telling Gukesh, like, it would be super cool if we have this space when we can talk about like how the sausage is made, right, and all these crazy ideas that we're having and how they kind of transform into it. Because like there is this, to some extent is improving, but there is this perception from people that core developers are these alien developers that I don't know, they go into this room and then Python happens. But it's just like we are just regular people, right? Exactly. So our idea was first kind of demystify a bit the core development thing. So it's not just, we're just regular people, right? Just doing the thing. And the other is that kind of trying to inspire people to join this, right? So ideally we can talk about like not only the projects that we're doing, but also like how hard it is or how we struggle. And we try to always have some inspirational notes on the episode so people can say, hey, maybe this is something that I want to do. And this was Gukesh's idea. We also try to highlight contributions that people have done, because like at the end of the day, people only know the big things, okay, the new parser or the JIT or the garbage collector or whatever it is, but there is a lot of very cool contributions for core developers or regular people that are contributing to CPython. So we spent at the end of the episode some time trying to go through the last, we call this section what's going on in CPython. And we try to highlight like the different things that people are doing, so people know about them, and hopefully like if a name comes again and again, like people say, hey, I know that person.
That's cool. So Lucas, Pablo speaks very fast. How do you keep up with him?
Experience. It's just a matter of just doing this for long enough. We've known each other for a few years before that, so I was prepared for the Spanish 2x, speaking speed.
Yeah, built-in 2x.
Right. Like we were joking, about this like many times, because people who are listening to our podcast, which for the most part is Python enthusiasts, but really the Python core team itself, so they're saying, yes, like this is the one podcast that they cannot listen to us at 2x because Pablo is speaking quickly. I am not speaking so fast. So maybe with this development of AI and everything, we should have some adaptive playback speed where it recognizes who is talking. And for me, it would be 2x. For Pablo, it would be like, whoa, no.
0.75, actually. I don't think it's 1x is enough. Funny enough,
some sort of normalization where they just both go to the same speed. That would be a cool feature.
We, as an anecdote, a small anecdote, we at PyCon, this is this big conference that happens every year. Well, there's several ones, but the big one is in the US. So I normally give like a talk every year. So especially in PyCon US, there is these people that try to transcribe live. So like people with hearing problems like can read. So it's really cool. And this year, I before giving the talk, I apologized to the person. It's like, I'm really sorry about what is going to happen, but I'm not be able to speak slower. And she was like, yeah, no problem. But like, oof, she really struggled with that. But yeah, she keep up. Like she was really good.
Yeah, the closed captioning at PyCon is a magical thing. It turns out that it does help people with, hearing disabilities to participate in the conference, but it's also helpful even for other participants, right? So just as subtitles are being turned on by most people watching now, like TV shows and other programs at home, the closed captions happen to be helpful for regular attendees as well. So this is something that has become a staple of PyCon US. I'm very happy that this is there. Definitely, some people present more of a challenge to the persons actually doing the closed captioning. I'm always amazed not just at how fast they go, but how much they can express the different TLAs and Python specific terms that we're using. You would think okay, like, this is very industry specific. And if you talk to your dad or, to some of your friends that are not in tech, some of the words, verbs, and so on that we're using might be mystifying. You don't even know how to spell this. And yet the people doing the closed captioning are excellent at this. You would be surprised how like obscure project names and so on, they are just perfectly able to spell just correctly. And it always touches my heart when I see my own name spelled correctly, which also does happen. They added me to their alphabet, so like, I'm like, this is awesome.
That is awesome. The personal touch means so much.
It does,
and it's worth going that extra mile in those circumstances. Well, we're here today to talk about Python 3.13. Hopefully, I'll be able to keep up with you, Pablo, because not only do you speak fast, but I'm kind of a visitor to your guys' world. So maybe keep them in check, Lucas. We're going to specifically talk about the biggest, and this is monumental. In fact, our community member who thought we should do an episode on this, shout out to Christian Klaus, says this is kind of massive for Pythonistas. This, the biggest feature coming out in 3.13, which should probably be out there if you're listening to this. We're shipping this October 2nd and slated to release October 1st officially. At least the RC is out there, but software and ship dates, we think it's probably out there. If not, coming very, very, very soon. The ability to disable or remove the global interpreter lock, or the GIL, as it's so lovingly referred to. Let's start at base principles. What is the GIL? And then after that, why would you want to remove it?
Right. So the GIL is basically a ginormous lock all around Python. So when Python is really, is the language, but it's really doesn't exist, right? Like it's an abstraction, and really normally there is a second language behind. In CPython is C, which is CPython is the default implementation of Python that normally people use. There are others, but then when this program that is the Python interpreter is executing Python code, it can have multiple threads at the same time, and all these little objects that Python exposes could be mutated at the same time, which is a problem. And Python in particular, CPython as well, and most of the implementations is reference counted. This means that to decide if an object is still alive or the interpreter can actually get rid of it, we have this little number inside every object that tells how many different structures or fields are using it, right? And when this number reaches 0, we know that we can remove it, right? But as any person who has done some multi-threading in computer science knows, having a little number being mutated by multiple threads at the same time is not bueno. So the solution is basically to add a ginormous lock all around the interpreter. So because we don't know what the threads are doing, we need to just basically lock the entire thing. So this means that only one thread at a time can be accessing Python code and executing Python code, which means that you can still use threads because those threads can switch from one to the other, which is what we call concurrency. Like you don't need to wait until one thread finishes to start the other. So they interleave, but there is no parallelism really, because only one thread at a time can be executing Python code, which is a big problem in these days when we have machines with 120 something cores if you have Threadripper or servers, right? Or even your phone, right? Like your phone have plenty of cores. And right now, you are running Python on iOS, which is now a thing, by the way. This is something
Python iOS is a thing as well. Let's earmark that for a future part of this conversation. So what you're saying is, when running Python, you can switch quickly between cores, but you can't actually run the same code on multiple cores at the exact same time. So you're saying it's concurrent, but it's not parallel.
Yes, correct.
Because of that lock, one at a time, and it can switch at the speed of light, but no true parallelism until now.
Right. So there were a few ways in which we worked around this obviously huge design limitation. So there are plenty of cases in which we're confident we can drop the global interpreter lock for what is happening on a particular thread. So if your particular thread is doing some big NumPy computation that is only on the sides of numbers that are not shared as Python objects, like you can drop the global interpreter lock in the time that this computation happens, so you can let other threads execute Python in that time. If your thread is waiting on a blocking network connection, it also does not need to hold the lock because that particular moment in time, there is not going to be any Python code executing. So you can give that GIL, right, to somebody else. So there are special cases in which we were already sort of parallel more than not, but it is very implicit. It depends on us carefully finding all those special cases and enabling them. And in the end, it does not scale for regular user applications. So if you just write Python code that loops over things and, just executes some string concatenations, does like all these regular things that you expect from a Python program, most of the time you're not going to be seeing any parallelism there.
Well, and what is worse, one important thing here is that technically a GIL is more than just a lock. It's a condition variable, which is a very specific kind of synchronization primitive. It's a Boolean that tells you have it or not, and an actual lock. And the thing is that you cannot select which, like when one thread says, "Oh, I don't need the GIL," like someone else, pick it up. You cannot select which one is going to do it. Like this is up to the OS. Like you are using Linux, so the Linux kernel decides who is the next one, and this can be not great because like the Linux kernel may not know what you're doing. So you can have one thread, for instance, that is super CPU hungry, like it's just crunching numbers. So that thread is like all the time wanting this GIL, right? And then you have many threads that are doing these IO operations. Maybe they are waiting on a socket or something like that. But because of how condition variables work and the scheduler in Linux works, which you can tweak a bit, but like not from Python normally, that CPU like thread will pick up that condition variable and the GIL many more times.
Right.
So it's almost like a race, right? When the GIL is released, it's like, you have a gun in a race, and then you fire the gun to signal that the race starts, and then all the threads try to grab it at the same time. And the first one that has it, that's the one that wins. But there is nothing preventing that thread to keep it like getting it the next time and the next time. So even if you are used to it and you can still say, well, maybe I can work with that limitation, it's very difficult to reason about it and to try to adapt it to your needs, because it's really up to the OS who gets the GIL or not.
This is one of the primary reasons why Python's reputation is being serviceable in terms of speed, but for certain workloads, certain things, it's too slow, right? Because of the GIL. This is one of the reasons why people will say, I might pick something else because of the GIL. Fair or not fair?
Yes. Well, like it's a factor.
It depends.
Yes, it's a factor.
Sure. Well, tell me why.
Right. So first of all, the speed of Python is mostly affected by the fact that it does a ton of indirection, right? Like the thing that costs the most in computer science, save for bad algorithms, is indirection. So every time where some language can just point at memory, read a value, and it's done, it's going to be faster than a language that, well, actually everything is dynamic. So you point at a value, but then that value has another value. So you have to go somewhere else in memory to read another value, then decide what to do, and read yet another value. So every time in Python that you're accessing an attribute, you're executing a ton of code compared to accessing a field in a struct in C. Mm-hmm. So that's going to be the main factor of it being slow. But the way where GIL is hampering us is scalability, which means simply for things that you could parallelize, you cannot do that effectively. So this is where the reputation of like, well, not really scalable comes in. But ironically, the GIL also makes Python faster than it would be without it. The reason why is because reference counting is a major reason for the global interpreter lock's existence. But it's not the only reason you need a lock in your interpreter. There's going to be internal data structures like dictionaries, where if you insert another key that wasn't there before, maybe there's going to be some rehashing that happens, right? So suddenly this simple operation is going to take a little more time than usual. So there's going to be a time, a split second, where the internal structure of the dictionary is inconsistent, right? For example, you would be able to see that it has more elements in terms of count than you actually are able to access, or you're going to be trying to access an element that is there. It claims it's there, but you cannot get it yet because the dictionary is being mutated, right? So for all those things, and there's plenty of cases like that, the global interpreter lock is very convenient because we are already holding it because we care about the reference counts to be always correct. So there's no other lock we need to care about. And this is actually making matters cheaper because we only have this one. And once you hold it, you can just run, and it's great. And plenty of authors of C extensions like NumPy and so on can also depend on the fact that as soon as you have the global interpreter lock, you have a lock that you can yourself depend on for your own synchronization needs. So now, without that, you're going to have fine-grained locking. So for every of those use cases that require synchronization, you're going to have a smaller lock. And it turns out that if you do this, then you gain scalability, but you pay the price of single-threaded performance, since catching, being able to acquire multiple locks is necessarily slower than just doing it once, right?
It also has other consequences apart from this particular aspect, which is correctness. Right now, if you have ever done like multi-threaded in a language which requires locks, like C or C++ or something like that, like when you don't have those locks, then you go into this thing that people call undefined behavior, right? Like unicorns can appear in your program and things can happen. In Python, because it's serial, like sure, the results can be garbage, but it's not going to crash because it's just one at a time. And this especially happens as well on these C extensions or these native extensions, which can be anything. Like if you have, you could think about it like, well, if I add one of these logs per extension, sure, I may have these problems that Gukesh is mentioning, but doesn't sound too bad. But like one of the problems, if you have many logs, is that now those logs can interact between themselves. So if one extension just happen to call another for any reason, like there is callbacks schedule or there is actually direct interaction or something like that, those logs now can do things like deadlocking or live logging or like reentrancy if you don't have something prepared. And remember that these extensions are made by different people. So like now you have bugs that only happen across them. And that is a nightmare. Like it's just real nightmare, right? And Regil is basically protecting this because there is one single one. So all of them share it. So it's very easy to reason about it compared to not having it.
Hey friends, we're big fans of Fly.io, and I'm here with Kurt Mackey, co-founder and CEO of Fly. Kurt, we've had some conversations, and I've heard you say that public clouds suck. What is your personal lens into public clouds sucking, and how does Fly not suck?
All right, so public clouds suck. I actually think most ways of hosting stuff on the internet sucks. And I have a lot of theories about why this is, but it almost doesn't matter. The reality is if I've built a new app for generating sandwich recipes because my family's just into specific types of sandwiches that use Braunschweiger as a component, for example. And then I want to put that somewhere. You go to AWS and it's harder than just going and getting a dedicated server from Hetzner. It's actually more complicated to figure out how to deploy my dumb sandwich app on top of AWS because it's not built for me as a developer to be productive with. It's built for other people. It's built for platform teams to kind of build the infrastructure of their dreams and hopefully create a new UX that's useful for the developers that they work with. And again, I feel like every time I talk about this, it's I'm just too impatient. I don't particularly want to go figure so many things out purely to put my sandwich app in front of people. And I don't particularly want to have to go talk to a platform team once my sandwich app becomes a huge startup and IPOs and I have to do a deploy. I kind of feel like all that stuff should just work for me without me having to go ask permission or talk to anyone else. And so this has informed a lot of how we've built Fly. We're still a public cloud. We still have a lot of very similar low-level primitives as the bigger guys. But in general, they're designed to be used directly by developers. They're not built for a platform team to kind of cobble together. They're designed to be useful quickly for developers. One of the ways we've thought about this is if you can turn a very difficult problem into a 2-hour problem, people will build much more interesting types of apps. And so this is why we've done things like made it easy to run an app multi-region. Most companies don't run multi-region apps on public clouds because it's functionally impossible to do without a huge amount of upfront effort. It's why we've made things like the virtual machine primitives behind just a simple API. Most people don't do code sandboxing or their own virtualization because it's just not really easy. There's just no path to that on top of the clouds. So in general, I feel it's not really fair of me to say public clouds suck because they were built for a different time. If you build one of these things starting in 2007, the world's very different than it is right now. And so a lot of what I'm saying, I think, is that public clouds are kind of old. And there's a new version of public clouds that we should all be building on top of that are definitely going to make me as a developer much happier than I was 5 or 6 years ago when I was kind of stuck in this quagmire.
So AWS was built for a different era, a different cloud era. And Fly, a public cloud, yes, but a public cloud built for developers who ship. That's a difference. And we here at Changelog are developers who ship. So you should trust us. Try out Fly, fly.io. Over 3 million apps, that includes us, have launched on Fly. They leverage the global Anycast load balancing, the zero config private networking, hardware isolation, instant WireGuard VPN connections with push button deployments, scaling to thousands of instances. This is the cloud you want. Check it out, fly.io. Again, fly.io. And I'm also here with Kyle Carberry, co-founder and CTO over at Coder.com. And they pair well with fly.io. Coder is an open source cloud development environment, a CDE. You can host this in your cloud or on premise. So Kyle, walk me through the process. A CDE lets developers put their development environment in the cloud. Walk me through the process. They get an invite from their platform team to join their Coder instance. They got to sign in, set up their keys, set up their code editor. How's it work?
Step one for them, we try to make it remarkably easy for the dev. We never gate any features ever for the developer. They'll click that link that their platform team sends out. They'll sign in with OIDC or Google, and they'll really just press one button to create a development environment. Now that might provision like a Kubernetes pod or an AWS VM. We'll show the user what's provisioned, but they don't really have to care. From that point, you'll see a couple buttons appear to open the editors that you're used to, like VS Code Desktop or VS Code through the web. Or you can install our CLI. Through our CLI, you really just log into Coder, and we take care of everything for you. When you SSH into a workspace, you don't have to worry about keys. It really just kind of like beautifully, magically works in the background for you and connects you to your workspace. We actually connect peer-to-peer as well. If the Coder server goes down for a second because of an upgrade, you don't have to worry about disconnects, and we always get you the lowest latency possible. One of our core values is we'll never be slower than SSH, period, full stop. And so we connect you peer-to-peer directly to the workspace, so it feels just as native as it possibly could.
Very cool. Thank you, Kyle. Well, friends, it might be time to consider a cloud development environment, a CDE, and open source is awesome, and Coder is fully open source. You can go to Coder.com right now, install Coder open source, start a premium trial, or get a demo. For me, my first step, I installed it on my Proxmox box and played with it. It was so cool. I loved it. Again, Coder.com, that's CODER.com.
So if you have slower single-threaded performance, you have loss of features in terms of it being or more complexity, potentially,
Right.
because your loss of a single lock. Now you need fine-grained locks and all kinds of other things you can do, which is problematic. And a huge lift by many developers over how long have you guys been working on this?
This has been many years in the making.
Many years in the making.
Yes.
Okay, add all those together. Worth it?
Well, we
We
don't
will
know.
see. We will see. We cannot answer that. We cannot answer that.
We don't know.
So we're in the stage of. So actually, this is an important thing, by the way, which I don't think we have mentioned. This in 3.13, indeed, there is a build of Python that will not have the global interpreted lock, but you don't get it by default. You need to manually compile Python. I mean, there is people that are distributing Python with this, so probably you don't need to manually do it. Like you can fetch it from your distribution, probably.
Somebody
or
will build it. Yeah.
Yes, exactly. But it's not the normal one. Like if you install Python 3.13, it has the GIL. Like
It's not like a flag that you give when you run Python. It's a separate executable.
yes, you need to. It's actually called Python 3.13T. Or free threading.
Yes.
But whatever. It's just,
Okay.
it's just the way it is.
Sure.
Don't
It's free
think about
threaded.
it. Yeah, exactly. Yeah,
Yes.
there you go. So you need to run that. And with that build, you can actually select at runtime, only with that one. You can select at runtime you want the GIL or not. And this is very useful in case you want to try the performance difference, or because you want to, like, imagine, for instance, you are doing one of these libraries and you want to test if your library works with and without, but you don't want to, run your CI with two builds or whatever. So you can do it. There are consequences of this because, for instance, in Python over the years, we have added a lot of new optimizations. Like, for instance, one of the things that I think Lucas was missing on the recent Python is law is that apart from this old indirection, and it's actually part of the reason, but is that it's dynamic, right? Like, so this is very important. Like if you are adding two variables X and Y, the interpreter is going to say, what is X? Oh, X is an integer. Okay, let me fetch the code for adding integers. Okay, what is Y? Ah, it's an integer. Okay, let me fetch the code. Okay. And then the next iteration of the loop is going to say the same thing. What is X? So like it's very annoying compared to just like, here's a bunch of bytes and I'm going to add this to this bunch of bytes because I know what they are, right? So in this particular case, precisely to avoid this dynamism, we have added a lot of optimizations that try to find this pattern. So they say, okay, you're adding these two variables together, But, the last 3,000 times I have seen this addition, there were integers. So, it's kind of a good chance that there are integers the next time. So I'm going to create this like super performance code that is going to just reach into the internals of the integer object in Python. It's going to grab the real integer and it's going to add it at C speed. And it's like, it's going to create a result like without asking all these stupid questions. And then it's going to box it again into a Python object. And it's much faster. You can still have a float suddenly and it will de-optimize and whatnot. But like that is good. Problem. All those optimizations don't work without the GIL because they are not thread safe. So if you use the single threaded version of the free threaded version, which is a bit of a mouthful, so you use Python 313T, but you don't have the GIL activated. You also don't have the optimizations activated because we don't know if they are safe or not. So what does this mean? It means that the free threaded version is slower in single threaded. So that you only run one thread and you're using the Python 313T version is slower because they don't have those optimizations activated.
Slower for now or slower for good?
Right.
For now.
Great question. So let's maybe take a step back and explain the kind of strategy that we took with this particular project, which is a huge undertaking. But at the same time, we have a release cadence that releases Pythons every year. Predictably, in October, you're going to get a new version of Python. So there's no way you can shove a big transition like this within 12 months. So what we're doing instead, essentially what you're getting is a state of the project as we are in right now. So there are things that we still need to do that are still not done. Most importantly, this split for the main interpreter still having the global interpreter lock and so on, and an experimental one that you have to build yourself and then you can run without a global interpreter lock, that is deliberate because with all those costs that we described, we really need to reach out to the community saying like, look, this is now not an idea. You can actually grab this Python and check whether this helps you. Is it better? Is it worthwhile, the scalability for this extra complexity within the implementation and maybe this cognitive complexity that is going to be sort of passed on to the user? Is that worth it? So the community will have to now step in and try out this new Python and see, okay, this is slower than the non-threaded version, but that's hopefully temporary. But the question to answer is, does the scalability that this enables help, right? So we really need them to give us 2 thumbs up, like, okay, keep actually working on this. Since this specialization that Pablo described and the JIT compilation that follows from that and so on are obviously features that we really want to have, including in the free threaded version. And there are ways to go around it, but they are very complex. It is, in fact, like on the bleeding edge of computer science as we know it. There are plenty of known strategies for improving performance of interpreted languages that are single-threaded. For free-threaded interpreted languages, this is really where the science sort of is still unclear, right? Because JavaScript, there has been so much investment in that, like making that fast with V8, right? Like in Chrome and so on and so on. Well, that is single-threaded, like for the intents and purposes of our understanding of the interpreter. With a free-threaded Python, how to make that fast is more of a challenge. Like literally members of our team are going to be the people writing papers about this later. So this is going to take time. Longer than 1 release, longer than 2 releases. But at the same time, we want to release what we already have so that it's no longer just a pipe dream. It's no longer just a plan or idea. Users can actually experiment with this and tell us, okay, this is actually awesome. This enables a use case we couldn't even try before. Because that's our chicken and egg problem. Before we actually enable this, we don't see use cases that are now impossible. So we cannot tell whether there's an untapped area of Python usage that would be now enabled with free threading. So this is what we're doing with 3.13. This is essentially this current state of the project. Now you can experiment whether you can see whether your web framework is going to be faster now, whether now you're going to be able to process data in parallel and so on and so on. This is essentially, one step of a longer project.
Right. And it's out there in release candidate. It's probably out there as we speak. at least in the official 3.13 experimental, as you guys pointed out. Are there early indicators? Are there people who have been just pining for this and they've already tried it in the RC and are saying, wow, we're seeing this, or no?
So actually, that's a very good point. So one of the things that actually surprised me a lot, because like we didn't knew, one of the unknowns here was how the community was going to adopt this. The reason being that it's just not that Python needs to be multi-threaded. It's that now if you compile C extensions, which are really, really popular in Python, right? That's one of the reasons so many people use Python the language, because all the machine learning doesn't happen in pure Python. It happens on compiled code and CUDA and GPUs, but like Python is the driver or the glue. So all that code needs to be changed or adapted at least, because now you don't have that lock protecting you, and like who knows what happens now, right? So you need to, which is really challenging, because right now you need to go through the entire code base, like the huge thing, and sanitize the code base through this particular problem, and there is not a manual for that if you think about it. Like, so you need to reason about the entire thing. And we were a bit scared about like how people will approach this, because or like what will happen, in the sense that if you don't do this or you don't do this correctly, it's going to crash all the time, or it's going to crash just once every blue moon or whatever, right? So we don't know. So one of the things that we have seen, and is really impressive, is that the community has jumped this incredible. Like people are building like 2 versions of every of these extensions, one for the normal build, one for the free threaded build, which is already huge, right? This doubles your CI time, doubles your storage for the extensions. So it's a lot of work actually, and there's a lot of people that are so excited to jump to these extensions, and they try to fix it and reason and like try these little locks all around. So all those people have been trying it, and one of the things I have been super surprised here is that once you add like those extensions and you have like a final application, like I don't know, a machine learning, whatever it is, right, or like an LLM or whatever you're thinking, that uses a lot of these things, right? It's just not one, like 5, 6, 7 really complex one, plus the interpreters, plus maybe a web server, something like that. And then you run it through the free threaded version, it just works. I mean, again, who knows? Like maybe every Saturday, just like you need your entire SRE team looking at it. But right now, like it's not mega crashing, because what we thought is that this was going to immediately crash, like when you add enough complexity to this, because it's just a statistics thing, right? Like the chances that there is some bad interaction when you put out of threads and the amount of code that is here is inevitable, right? And it's still, we from time to time we find very funky shit in the interpreter when you call a method and sometimes like another method is called because like there was something like a memory reordering problem, which is a very technical like deep thing, right? But and the bug in that particular thing is just hell. But like that is very rare, and obviously we fix it immediately. And we are really surprised about, first, how many people have jumped at this and they're super excited and they want all of those extensions and working. And second, how quote unquote stable this is, meaning that how little bugs we have seen in the wild. Like we expected many more, right? And we are seeing very little. So right now it's super promising.
Yeah, like what does help is that we do have the people behind it, like Sam Gross, who actually did the prototype of 3.9 and then 3.12, now who is working on making this for 3.13 and forwards, is being helped by other engineers who are like really into this and are able to find thread safety issues and data races and so on. We were able to set up Thread Sanitizer, which is very complex to set up in an interpreter environment like Python. Turns out it does help us with finding those issues. Some of them are pretty funny, like figuring out that for this entire time, the thread handle in Python was not thread safe itself, or the threading lock was not thread safe itself. So like once you actually like did the operations of locking, yes, those were thread safe, but the Python object that you used was not, because it didn't have to be. And now like all of those things have to be actually like fixed, so they are probably formally correct now. So yeah, like there's been a lot of work, and a lot of work is still to be done. But we are, kind of, our hearts are warmed by how little, terrible and unsolvable issues we've seen so far. Some of them are like, complex to debug and complex to diagnose, but we've been successful in, improving the situation so far as we go.
So for your average programmer out there with their average Python app, whether it be a web app or a desktop app or whatever, should they be hopping on this experimental and giving it a try? Or is it a thing where it's like, if you don't know that your code is thread safe, it's probably not? Or is it the other way around? Like, what's the water feel like? Is it warm? Are there alligators in there?
It depends, right? Like if they are paid to make sure that the thing is stable, the recommendation is not. Like because try it out, sure. You can get very excited, by the way. Like one of the things that we have seen a lot of me myself, right? Like for instance, I'm at the company I work, Bloomberg, is that we have tried like to see what will happen. Like even if it crashes from one every 3 months, right? Whatever it is, but just to see a sense of like what is the improvement here. Because like if then down the line you're going to justify any effort on your side to adapt your thing to the free thread version, it's very good that you know what you're going to gain. So that for sure. Trying. Really, we really want people to try and tell us what they see and like what doesn't work. Is this a production ready workload? Absolutely not. Because not because we know it's going to crash or anything, but because we don't know the real status of the thing, right? Like we take stability very, very, very seriously in the core team. So we are not comfortable right now. That's why the thing is called experimental. Because we are not comfortable right now recommending people, especially when you not only have the interpreter, but all these other things, right? Like, and still we need to figure out like good APIs for those extensions to, hook into the interpreter and things like that. And that is not there right now. So the chances that we can look at these things and say, yeah, this can run in production, no problem, is almost zero right now. But as we release Python 3.14 and 15, we will move this experimental into supported, which means that you can run it in production, but there still will be 2 versions. And eventually, when we gain enough confidence that this is the future we all wanted, it will be only one Python, which will be Python without the free thread version. But until we call it stable and supported, that's the keyword, supported, I wouldn't recommend people to actually use it in production environments.
Yeah, production environments. However, I would be a little more optimistic about this, saying that if you are an end user, probably the amusement park is still being built for you. So like that, this is not like something that is ready for end consumption, unless you are really just trying to just see how pure Python works without all the libraries that you depend on. However, if you are a maintainer of a library that a lot of people depend on, you might be interested in checking it right now, right? Like, so we already see plenty of interest from the data science libraries and web frameworks and so on and so on. And that's exactly the right moment for them to identify whether there's any blocking issues or whether the gains are not enough for us to justify the change, or maybe the opposite, or maybe they're amazed at how better things are right now. Funnily enough, even things that were not ever designed with free threading in mind, like Async.io. Like you run the test suite of Async.io and it's just faster on free threading because it just can magically utilize the fact that it is now truly parallel. So there is promise there. Definitely, we expect that, once the library authors actually, go through some of those hoops that are required for their things to be supported by the free threaded version, we're going to see uptake on more libraries and then more users and so on. So now's the time for the library maintainers to check it out. But for end users, it is a little soon.
That makes a lot of sense. Somebody should start a list of libraries which have taken that initiative.
There is a list like that right now. There is a website. I forget the name right now. Like, we might add this to the metadata of this episode so that you can check this out. Just as in the Python 2 to 3 transition, we had a list like this. There is a list. It is very fresh, so I forget the website name right now. But it's there. It's there.
Cool. Very cool. Well, it's definitely exciting times. I'm even excited, and I don't use Python on the regular, but I think that's early indicators of something that's potentially a huge success. So congrats to you guys and the whole team for the effort, at least, to make it no longer theoretical and make it an actual piece of software, bleeding edge piece of software that's going to produce even some papers. Should we move on to the JIT? Lucas, you mentioned the JIT is another feature, 3.13, or is there more to say about the GIL? I'm assuming these things will probably interact as topics.
Right. So the JIT is still like one of those other topics that I remember being this big, pipe dream of CPython for as long as I can remember, right? We grew a few attempts to have a JIT in forks of Python or entirely new Python interpreters. Most of those efforts failed. There's one holdout that is actually doing very well. That's PyPy. And that is actually JITted, which proves that this language can successfully use this, performance strategy for good results.
As a clarification also for the people that don't know, PyPy is not a JIT for CPython. It's an entire different interpreter.
Yes.
So it's like the same language, but it's just a different interpreter written actually in Python, which is JITted then, but it's a separate thing.
Yes, it is an entirely separate technological stack. It is attempting to be bug-to-bug compatible with CPython. People adopting it have seen, your mileage may vary sort of, results where it might be really a drop-in replacement in some cases. It might be more tricky to actually adopt it otherwise. Plus, the approach of JITting they're using is has some characteristics with memory usage being larger and so on. So depends on your use case. But obviously, the most popular version of Python is CPython is the version that we are working on. So this is an idea that just comes back and comes back and comes back. Like, when will Python have a just-in-time compiler? So to like a large approximation, if you squint really hard, this specialization that Pablo already mentioned is sort of slowly becoming a form of what the JITs are doing, which is to remove all this indirection. But the last step that they did not take so far, those optimizations, is to actually replace running this C code with this C code with an actual compilation to machine code as we go dynamically, which is what the JIT is doing. And Brant Booker, one of our core team members, found out this paper about how you can automatically generate a JIT for the Lua interpreter and how it is slower than a handwritten JIT, but not by that much as you would expect, and it is much more maintainable. And using this approach, with this additional machinery that is needed for the just-time compiler that tries to compile during our build time, like the simple opcodes that are later glued together to this optimized machine code and so on, and to discover whether that trace that we're running is still correct, or maybe we need to throw it away because we thought this thing that we're running is like adding to integers, right? But now we're seeing, there's a float that we did not expect. So we need to throw out this optimized code and actually go back to the interpreter again. So all this infrastructure is already in 3.13. And so far, we can proudly say that with all this added, Python is not slower, right?
0% faster.
Yes, it is 0% faster because, again, with the release cadence that we're having, 12 months of work is a lot, right? Obviously, but it is not enough to just say we started from 0 JIT and ended up with a mature JIT like V8. We are done. It is just simply impossible, especially that our team is much smaller than the V8 teams, much smaller than the Java hotspot team, and so on and so on. So far, there is another experimental feature in Python 3.13, which is the JIT. You have to compile with that, and you have to enable it when you're running Python. So it does not have most of the optimizations that you would expect from the just-in-time compiler, because that entire technology of just-in-time compilation is essentially a framework on top of which you can now make optimizations that make things faster. For example, if within the trace that you're building, connecting all those machine code blocks that are now faster and removing indirection, you have multiple checks whether something is none or something is an integer. You can move that check of that same piece of data to the front of the trace and just do that check once, and you don't have to repeat it in different parts of the code, and so on. And to make sure that the traces are as long as possible, those are different, kind of levels of optimization. You want to JIT relatively quickly so that people can see the uplift very quickly, but you don't want to JIT every code that is being executed because that would make the memory usage crazy. So there's, things that you need to dial in there and implement. So it is very much an in-progress project. It looks very promising, But so far, Python 3.13 is a snapshot of the current stage of that effort as well.
Pablo, anything to add?
Well, one of the things that is very exciting with the JIT right now is that the approach itself is quite cool. Like, for instance, if you're making a JIT for a dynamic language, one of the biggest challenges is not only adding the infrastructure itself for a particular CPU, but like architecture, is that you need to do it for all of them and for every single OS, because at the end you're writing machine code, and machine code depends on your CPU architecture, your platform. So you need one. So the JIT is not the JIT, or as we like to call it, legit. But you need one for Python. Sorry, one for Windows, one for macOS, one for Linux, but also one for AMD 64, one for AR64, one for ARM v7. So you can imagine how hard this actually is, because you basically are implementing now a compiler, right? So, but this approach that Brand is taking not only has the advantage that is basically leveraging an existing compiler behind, in this particular case, LLVM, but also is doing it at the front. So it doesn't happen at compile time. Like, all that assembly code has been generated before, and the only thing that we need to do at runtime is stitch those things together. Mm-hmm. So we have these templates. So Clang is basically, or LLVM is not a runtime dependency. Like, it's just a build time dependency. So you build all these assembly code, and it uses the native compiler for your platform. So if you're in some forsaken platform, like, I don't know, AX or something like that, it will work if you are able to run Clang there. So that's great. But also, which is really cool, and most JITs need to also implement themselves, is that we are able to leverage an optimizing compiler for this particular workload, right? So not only that assembly code works for every architecture because someone else actually implemented the backend, but also we can leverage all the optimizations that everybody that's using LLVM is using. It's the same optimizations that Rust is using, right? Rust is using LLVM these days still, and they are using, if you program the IR, the intermediate representation, correctly, and then you are able to leverage that well, which is not, it's easier said than done. But the idea is that now you can use this set common of these many years of compiler research just to make your code faster, and we can just leverage that immediately, as opposed to having to re-implement all those things and have like SSA ourselves and trimming and all that stuff. Like, now, you just run Clang, you get some super cool assembly out. We need to just stitch it together and feel like the symbols and whatnot. But it's a much, you can get the results much, much faster than if we need to implement a full-blown JIT for Python. So very excited.
It's like a JIT factory.
Yeah, literally. Right. Java style.
You guys use factories in Python?
JIT template factory.
What's up, friends? I'm here in the breaks with Dennis Pillarinos, founder and CEO of Unblocked. Check them out at getunblocked.com. It's for all the hows, whys, and WTFs. So Dennis, we speak to developers. Who is Unblocked best for? Who needs to use it?
Yeah, Unblocked helps large teams with old code bases understand why something has been done in the past. It helps them understand what happens if they make changes to it. Basically, all the questions that you would typically ask a coworker, you no longer have to interrupt them. You don't have to wait for their response. You don't have to, if you're geographically distributed, you don't have to wait for that response. You don't have to wait for, you don't have to dig through documentation. You don't have to try to find the answer in Confluence and Jira. What we basically do is give you the answer by you just asking a question. The way that we got to the problem was a consequence of our kind of lived experience. We were actually going to call the company Bother, which is like, you don't bother me, I don't bother you, right? Instead of being tapped on the shoulder or interruptive Slack messages, we could just use Bother and get the answers that we wanted. We didn't go with that name because it's a little bit of a negative connotation, but helping developers get Unblocked by answering questions or surfacing data and discussions within the context of their IDE relative to the code that they're looking at is something that thousands of developers love so far.
I think our listeners are really familiar with AI tooling, very familiar with code generation, LLMs. How is Unblocked different from what else is out there?
A lot of code generation tools help you write the code to solve a problem. We sit upstream of that. Our goal is to help provide the context that you need. If you think about where you spend your time when you're trying to solve a new problem, understanding how that system works, why it was built that way. What are the ramifications of changing something? That's the problem that Unblock tries to solve for you. We take the data and discussions of all of these, the source code in all of those systems, to provide that answer for you so that you can get that context and then you can go and write that code. We had this great example of a company who hires, very competent developers. It took them 5 days, that developer 5 days, to write 12 lines of code. And his feedback to us was, it's not that it takes you 5 days to write 12 lines of code. It took them 5 days to get the information that they needed to write those 12 lines of code. And then it takes probably about 30 minutes to write those 12 lines of code and rip off that PR.
Okay, the next step to get unblocked for you and your team is to go to getunblocked.com. Yourself, your team can now find the answer they need to get their jobs done and not have to bother anyone else on the team, take a meeting, or waste any time whatsoever. Again, getunblocked.com. That's getunblocked.com and get unblocked.
If we could move this conversation up a level for a moment, do you guys like this 1 year release cadence? It seems like it has its drawbacks.
This guy implemented that idea. So, what do you think he's going to say?
Who did? You did this?
Yes. So we can make this like good cop, bad cop, or actually
let's do it.
Devil's advocate, and this guy who's trying to convince you this is good. So I'm also the release manager of some ancient Python versions. In fact, when Python 3.13 comes out, the first version I released, which is Python 3.8, is going end of life. So, we're going to say goodbye to that. It was a very, very, nice release. I really enjoyed Python 3.8, but it's time to move on. So if your use case, if your production is still running on 3.8, well, now it's high time to move, since it's not going to receive any security updates anymore. Right. So at the time I joined as the release manager, the release process was a little bit hand-wavy in terms of when are we releasing Python. So the theory said we're releasing it every 18-month-ish, but it could be anywhere between 18 and 2 years. And, you couldn't really tell. And definitely what you could not expect was which time of the year is this going to happen in. And the consequence of this was that Linux distributions in particular, but also other operating systems and end users, were lagging behind adoption of Python 3 versions a lot. People are like, well, Python 2, no, because Python 2.7, right? But Python 2.7 was out and then essentially frozen for a long, long time. So people forgot how this thing looked like before in times of Python 2.3, 2.4, 2.5, 2.6, and then 2.7. That unstable release cadence was problematic. And that caused, for example, for Fedora, which later is source for what is happening in Red Hat, was lagging behind with the releases that we had. And it turns out that the infrastructure that the big Linux distributions have, like Ubuntu and like Red Hat, is extremely useful for us to early find bugs in a new version that we are developing, in the betas, in the release candidates, and so on. So it would be worthwhile if we could actually ship the newest version of Python with those Linux distributions as they are also developed and go through their respective betas and so on. That's also great for the end user, right? Because then by your autumn release of Fedora, you are released with the newest version of Python that was just released. That is a great experience for the end user. So I wrote a PEP, a Python enhancement proposal document, arguing those things that I'm just telling you, that it would be amazing to have a fixed release cadence, like that we can trust and share with the Linux distributions, such that they can essentially rely on us having certain milestones in the release, like reaching beta 1, like reaching release candidate 1, so that they can use the latest version as soon as possible. And we switched to that release cadence in Python 3.9, and we've been using it ever since. So yeah, Your Honor, that's my position on this issue.
Well, as the other release manager of Unseen version now, So I released 3.10 and 3.11. I mean, one of the problems that this thing I mean, it has worked really well, I think. Like people in general, and just to be clear, like, so Gukesh doesn't kill me after we finish the podcast. Like, I think it's a positive change, right? Like, and so in general, very good. I think it has bring some predictability.
Yeah.
People actually now have like dates, and they can put their lives around. One of the interesting side effects of this is that now people have this impression that Python is releasing too often. So every single year is a new version, and then the old version becomes like out of support, or like first bug fix support and then security support. So they have this feeling that they are going to be if they don't move fast enough, they are going to be out of support super soon, which was always true. It's just that you get the numbers like changing slower, so the impression was that it's happening slower. But right now, this is like moving this impression that Python is changing too quickly, right, or whatever it is. The other downside that this has is that, as you can see, for instance, for Python 3.13, it means that because we need to release every single year, we're releasing these features, maybe like big ones, like the no-GIL or the JIT in particular, not being super exciting. So, for instance, the JIT in particular is 0% faster. Well, it's kind of cool, but where would you use it? Well, if we have a 2-year release, maybe it will be a bit better. So you get these weird situations. So planning big projects right now is a bit more challenging. For instance, one of the things that happened in Python 3.9, if I recall, we changed the entire parser of the language.
Yes.
Like bonk, different parser, which I'd like to describe as changing the wheels of a car that is moving. Not the best feeling. But that was a bit like that could have we could have some extra rest if that was a 2-year release cadence and we didn't have to like finish everything and all the validation in 1 year. I mean, this doesn't mean that it was rushed. It's just that we have to put more hours just because we wanted to make to the release. But on the other hand, like this it's humans making it. So even before when the situation was like Gukesh was describing, the day of beta freeze, which is the moment when that no new features can come in and only bug fixes from that point on in the release, everybody was rushing their feature at the last day, like
Right.
all the new features to do, like so humans are humans, so it doesn't really matter. But that's one of the certainly the heat has been raised a bit because like right now it's released more often and the numbers are changing faster.
That was more the angle I was coming from, was from the when the train leaves the station once a year, you better get your stuff on it, whether it's ready or not.
Right.
And I appreciate, I didn't know the history of where it came from, so I think this is definitely progress and improvement, predictability, each time of year it's going to go out, et cetera, et cetera. And it makes a lot of sense, especially a large project like this with tons of people using it. You want to be predictable, but also not too frequent. I would probably tend towards more frequent because now you have the train leaving the station more times. And if you miss this one, that's all right. We got another train leaving 6 weeks from now. And so you can hop on when it's ready versus having to hop on once a year. And that's, we've seen success in projects like Chrome, et cetera, with like rolling every 6 weeks, whatever's ready, we're going to ship a new version. I don't know if that works with languages and runtimes. You guys know way better than I do, which is why I asked the question.
Right. Like, I guess for compiled languages that might, in fact, like work better. For us, the difference is that we're interpreted. So there's a lot of code that is lying next to your interpreter, and then you're trying to run it with whatever is available to you. With a lot of the libraries that we're supporting, they're a particular issue. So, like now I'm going to be the devil's advocate because like Pablo was too apologetic. So let me
Wow.
Yeah.
Sounds fire.
Yeah. Let me just say hey, this is all a compromise, and there's obviously going to be things that are better and things that are worse.
Right.
The price to be paid for shorter release cadences is that the matrix of tests of CI that a library maintainer has to now kind of suffer with, so it has to run, is larger, right? Because the number of versions that is out there that people are using, there's just more versions than there were before, right? You had 2.7 and 3.6 maybe, and then 3.7 appeared some 18 or 19 months later. So the growth of this matrix was sort of spread out in time. Now that matrix is bigger. I would claim that, okay, it's good that we're testing with every particular version to identify where an incompatibility arose or something. However, I always like to say that it's still the same sausage, right? We're still the same sort of team that is developing the thing. We still have the same velocity, only we slice it thinner now. So every release is easier to migrate to compared to like the last release because
that's a very good point. That's a very
there were
good point.
fewer changes.
Yeah, psychologically speaking, that's a very good point actually. That I'm glad that you mentioned, because like one of the things that happen when you release every 2 years or more, especially for a language that needs to evolve and needs to change things, and maybe doesn't have. I mean, we care out about backwards compatibility. Don't get me wrong, but like other languages like C++ clearly care even more. So for a language that changes this much, changing and adapting your code and all the libraries for a 2-year worth of changes is brutal. Which means that, and we saw that before, right? Like, which means that like until new libraries are compatible with the new version, there is a non-trivial amount of time. So as a user or as a company employee that you want to leverage these new features, you probably want to wait a lot, because now people talk about the scheduling the work and and finding even how much it is. And library maintainer says, well, I will fix it later. But when the changes are smaller, there is, like, psychologically speaking, obviously in reality is more or less the same modulus and nonlinear interaction. But like, in general, when the changes are smaller, then it's more enticing, because like at least okay, maybe it's this and this thing. And sure, maybe you need to wait for another library to do it. But like normally, like, and right now, what we have seen compared with 3.8 when we started doing this, right, is that people jump earlier. Like before, for instance, one of the biggest libraries is in this NumPy, which is numerical computing done in C, right, and Fortran and whatnot. So that library used to take a long time to be compatible with new versions, like months, right, or sometimes even like half a year or something. And right now we are having it almost day one. So this is fantastic, because like people that want to use the new features in the language, they are not held back by the fact that their own particular dependencies don't know how to have the support for this. So most of these things, I don't think you can approach it from a data-driven kind of like perspective, because it's very difficult to say what is better, what is worse. But like certainly, like from a psychological point of view, I think again, I think you have a very good point. Like not too soon, like not too often, sorry, but like also not too like lagging behind. I think it's earlier is better, maybe not too early. Like every 3 weeks it will be impossible for a compiled language. Like we will ship a JIT compiler that uncompiles and optimizes your code, right? Like it will be like 6% slower or something. But 1 year, yeah, good.
I want to add one thing. So NumPy is not doing as well as Pablo is claiming. They're doing way better. There are already wheels for Python 3.13 before the release of Python 3.13. Those wheels are going to work on the final version of Python 3.13 released October 1st. We're releasing this like mid-September. They're already there. Moreover, they're also already there for the specific version that is this experimental interpreter that does not have the GIL. So
I think everyone, a non-trivial amount of listeners probably are like saying like, what is a wheel? Like, what is this thing?
Yeah, so it's this binary package that lives on the Python package index on PyPI that people download NumPy from when they say pip install NumPy. So if you say pip install NumPy from Python 3.13 on day one, you're going to be using wheels that are already there before the release of Python 3.
Is this another word for a build? It's like a build?
Basically it's a binary package. So it's a package that doesn't contain Python code only.
Why do we make up another term for it?
Well, this is the key, right? Because the Python package index used to, well, I think it still is, it's called the cheese shop, because it's all about like these Monty Python references and jokes, right? So it's a sketch of the Monty Python that goes to this cheese shop, and a wheel is a wheel of cheese. So ha ha ha.
All right, taking that one a bit too far, maybe.
Or like pip, pip? I mean, this is a slightly different joke, but like, pip? Pip is the package installer for Python, right? So when you install a Python, you do pip install. Do you know what pip means?
Python install packages?
Pip installs packages.
Yes.
Okay. So a recursive acronym.
Recursive.
Yeah. Recursive acronyms I'm well aware of, but I'm not a Monty Python guy, so I missed completely this reference.
Right. So, well, I was missing this reference for years, and someone pointed it out, and I said, like, well, I suppose it makes sense.
Like, I have to watch it. Is it from Holy Grail, or which movie is this?
No, I think it's one of the Flying Circus, maybe.
Yes, one of the episodes of the Flying Circus has a skit about the cheese shop, and that's where that comes
This is
from.
an obscure reference to build an entire Python ecosystem around, but okay.
I think it's not helping for Python programmers look like they're in a Coven or something.
But
like,
you just need to have some. You just have to have some file extension for those things and some name for those things. We used to have a more primitive early format for this sort of thing, and those were called eggs. Eggs were because, snakes lay eggs, right? So that made this other sort of reference, because Python in the name comes from Monty Python, but a lot of people just see the name Python and they're like, yeah, snakes are cool, so snakes. We accept both sort of ways of interpreting this because snakes are indeed cool. Yes, sure. But yeah, like now that we knew that eggs are not enough for what we need for proper binary packages, we were like, where to go now with names? And naming is hard. Let me tell you this much. Like, naming is very hard. So
someone jumping in the middle of the podcast listening to us talk about eggs and snakes. It's like, wasn't this about tech?
Again, this background is spectacular because you do run out of references with snakes. Like, how many things can you actually reference? But with Monty Python, there's just countless references you can make. Just people won't get them.
But yeah, they're very obscure these days. Like, it's an increasingly old and hard to get. Like,
For instance, one of the funny ones, one of these attempts at JIT compilers from back in the day, I think from Google, was called Aladdin Swallow. Like from the Monty Python.
Okay.
Life of Brian. No.
Sorry, Holy Grail.
Holy Grail. Yeah. Like
Holy Grail.
The speed of the unlighted swallow.
Yes.
Good stuff. Okay, good meta conversation on release cadence. I think I agree with all your points. You have to find that sweet spot and as frequent as you can be reliable without being too frequent. And that probably varies per project. And I'm happy that you guys are happy with once a year. Certainly better than what y'all were doing before. That's very cool. Let's go back to Python 3.13 because Pablo, at the beginning, you mentioned it's officially iOS compatible or something. What does this mean? Like, you can just fire up Python on your iPhone, or?
Well, not quite yet, I will say. But like one of the things that so CPython has a very old build system, right? It's Auto Tools, which is this configure make, right? People that have been like doing Linux for a long time probably have run into this. And one of the challenges of this is that and then it's like another different for Windows, but like both macOS and most like Unix platforms use that. So for a long time that was okay, but there was like a lot of platforms that we couldn't support just because like partially because the build system and partially because the source requires changes. Like for instance, like many of the things the efforts that we're trying to do right now to make Python available in the browser. I don't know if you have heard about this, but right now there is a good effort to ensure that Python can run in the browser and it's a good alternative to JavaScript. This is a project, for instance, called PyScript, which allows people to run like Python as instead of JavaScript, which is quite cool. So those require changes in these like build systems and even in the source of itself. And iOS in particular has quite a lot of challenges. Actually, probably Gukesh can chime in to specify those since this is very close to his heart. But one person in particular that has been working for iOS support, which is Russell Keith-McGee. Yeah, he works right now at Anaconda, which is one of these Python companies. So he has been working quite hard to ensure that both the build system and the source itself, it works on iOS, which has a lot of challenges, right? Because iOS has not only like a alien way of doing things, but many APIs are not available there, or others are available, but you need these specific things that you need to Apple to bless you with their power just to be able to use. Like the JIT compiler, like how does the JIT compiler write iOS? Like who knows? Probably cannot.
Maybe let's start like from the very beginning there. So the goal that we have with this iOS support, for the time being at least, is not to have an application on the App Store called Python. That's not what we're doing. What we are doing right now is to have the Python distribution, the source distribution, ready entirely for being embedded within another application that somebody wants to release on the App Store for iOS, right? This was theoretically possible in the past with already a ton of hacks that Russell Keith-McGee historically made for a project called Beware that is just running Python on mobile on both Android and iOS. But the Python source code, our source distribution, was not making this easy. There are plenty of changes that you may have to make because the phone platform like that Apple came up with is very limited. It is limited kind of by design, such that it's more secure and it's sort of doesn't waste your battery too much, and it does a bunch of other things that make it easier for applications to be just swiped up to kill them, and they don't run any runaway processes and whatnot. So there are APIs there that are not allowed. There are others that are just not implemented, so they're not available. So you cannot run threads and so on. So this sort of thing causes embedding Python to be complex. And then there's the new and increasingly strict rules around when you're packaging some sort of binary blob and want to put it on the official app store for Apple. They have this automated and sometimes in person, but mostly automated review process, whether what you're publishing is safe. So there's plenty of things that interpreted language like Python would do that would be flagged by those automated systems as unsafe, that this code is doing something fishy. So there are changes needed for those things to just pass review so that your application that embeds Python can successfully actually appear on the App Store. Like including until very recently, you couldn't really have just dynamic libraries lying around in your bundle that you're publishing on the App Store. Everything had to be statically compiled, which puts, depending on libraries like NumPy, into jeopardy because it is very hard for like external C extensions to be built in a way that they are both all part of a single binary. Now this extension is lifted. However, you have to sign everything that you're publishing to the App Store separately. So it has to be notarized by Apple. It has to be signed with your application developer certificate and so on. So, you know, when you're sending out this code to Apple that, okay, this is the code I built, nobody meddle with it. And then Apple notarizes it that, okay, this one is safe to be run by, users' phones and so on. So all this infrastructure, like it seems like something that shouldn't really be our concern. But all of this was making it hard for Python to just be embedded. And now with Russell's hard work, this is a platform that we support. So if you want to have a text editor that has automation in Python, if you do want to have an editor for Python source code, like there's a few of those, like Pythonista, Pyto, and so on. Now it's going to be much easier for the authors of those to upgrade to a newer version of Python. This is why all those apps lagged behind and they were still on Python 3.8 or 3.10, because it was a ton of work to upgrade and redo all those hacks in a newer Python version. So now, unnecessary, we support it.
That definitely wasn't what I was thinking, but it makes a ton of sense. I think it's going to make some people very excited.
What were you thinking about?
Yeah. What were you thinking about?
We're going to write some Python code and deploy an app based on it, like build an app in Python.
Right. So this is kind of step 2 for the Beware project that Russell Keith McGee is part of and which is now being essentially sponsored by Anaconda, where, you're going to be able to build Python applications from scratch and end up with an app on the iPhone that you can put on the App Store and it's fine, right? But the first step of this is that all this additional tooling that Beware is building on top of Python needs to rely on Python being embeddable.
Right.
So,
also, conceptually speaking, is not different from the first use case because, like, you are not going to have one single Python in the App Store that everybody can use, and you need to have everyone will have a different Python version. So it's a trivial embedding. So you are not embedding this on a text editor, you're embedding it on a binary that is just Python.
Yes.
But you also want to ship, not only your Python code, you want to ship your dependencies as well, right? So now, but this is the same. Like if a text editor, you want a text editor to have Python inside to do some extension, you may want some extensions that Python can do to interact with something else, right? So maybe you want also that on the dependencies. So it's technically, if you squint hard enough, it's really the same case. It's just that for the developer that just wants, to put some files and maybe to say, I require this and that, that's a lot of work. And, you're in the business of compiling Python yourself. Like, what are you talking about? So it's much better if we can offer a specific workflow that says, okay, if your case is only this and that, and you only have these dependencies, then, you just click this, put this here, and the build process will take that for you, so you don't need to. That's the step 2. But conceptually speaking, it's just a dev tooling, not really a huge undertaking.
But really, it's it's again incremental steps. So the important thing here is as well that this is now part of our CI. We are building Python on iOS every time you make a change. So it's going to be much less probable for us to introduce changes without knowing that they break support for running this on the phone, which should be great news for anybody that actually wants to see Python on mobile devices, because now we are going to care to keep this running.
Well, now you have me thinking about the future. Let's close on this wish list. Imagine that the three of us are sitting down next September and talking about 3.14. What do you want us to be talking about? What do you hope we're talking about going into 3.14, each of you?
Oh, okay. So my dreams are simple. I want everything.
I like that.
Honestly, I sponsored the, making Gil the optional PEP. So this is very close to my heart. What I would like to see is for this to pay off, for the library developers to step in, try it out, and say like, hey, actually, this is helping us. What is related to this, to see that the performance, efforts that we are having separately from the global interpret lock removal actually converge and, kind of do work with this free-threaded version. And also, finally, again, free threading. We don't expect people to actually start new threads randomly and end up in this, crazy world of free threading where you can just easily just write bad applications by writing on top of your variables and accessing data you shouldn't. And, we don't want to reintroduce models that already we know failed in other languages. We want tooling to be more high level. So I want this more high level tooling to start popping up slowly. We deliberately didn't suggest any so far. We want to see what the community actually wants to use. There's kind of things that happened in other more younger programming languages. You have Go routines, right? Like you have channels in different programming languages and so on. So I'm very excited to see where this goes. So this free threading evolution is what I would like to be able to tell you next year that, has done great leaps and it's now way more usable and it's literally the future. So, yeah.
Well, in my case, I think, apart from subscribing what Gukesh just said, I think the key for me is that this pays off, like, which is non-trivial, right? Like it may pay off for some users for sure that are really hungry about this. Like what I really want to know is that people, like, for a lot of time, like removing the GIL has been almost like joke about, like, this is what is missing, like, that this will be like the last thing and everything will be so green and fantastic when we remove the GIL. Well, now prove it. So I want to see like everybody saying like, now that there is no GIL, I finally can do this and dip this thing, which is not going to happen fully, right? Because like, people still will reach to other languages for other reasons and performance, right? But like, I just want to see a big impact there. And ideally, we talk again for 3.14, like we are saying, okay, this make a difference, right? So it was cool, sure, like, and some people really like it, but like, wow, like now it's a different playfield, right? Like, so it's different. The other thing that I would like to see, and this is a bit more personal, so this is a project that I started, I think, Python 3.10, and which is that a lot of people were complaining that the kind of the user experience of the language was not really great in terms of like error messages and things like that. So like, syntax errors and like you mistype something and or like there is some import problem. So that was really bad, like to the point that there were some situations that was laughable. And we have worked quite a lot, like with the new parsers and with many other improvements to improve this, to the point that right now I'm super happy to see that many, like even papers that are researching error messages are citing Python as like one of the, obviously not in the same category as Rust, because like we can all agree that Rust has fantastic error messages. Different kind, because those are compile time error messages, and we are talking about runtime ones, if you don't consider the parser. But we are right now like quite high in that sense, to the point that I think there was some research about like how LLMs can reason about what's wrong about your code from the errors, and you run it in 3.11, it was like a 30% like better performance of those LLMs, just because it's telling you a bit more, right? So you can fix the code a bit better, which is quite cool. So we continue doing this thing, and we are trying to add like even bigger changes to the interpreter that help in this regard, which is challenging because those changes sometimes require some non-trivial performance games there. So obviously we don't want to affect performance, but to do that we need to like put a lot of engineering there. So in 3.14, we are probably going to try like some new ones that are quite big. So we want to see, hopefully when we talk again, those have actually been implemented and they have been successful, which I would love to see.
Yeah, that's awesome. I was reading about your improved error messages, and I think that's the kind of thing that has to be a sustained effort over time. It's like one of those paper cuts kind of things where it's like, we're just going to continue to polish this thing. And so a great effort. I'm glad that you struck that up. Well, the podcast, Core.py, if you are a super Python nerd and want to nerd out with these two about internals, on a more frequent basis, then we'll cover it here on the Changelog, which sounds like it's going to be about once a year. Love to have you guys back next September and be talking about 3.14. Hopefully, all of our wishes will have come to fruition, and we'll have people out there free threading it.
Right, free threading it.
Cue Leonard Skinner here. And enjoying the new Python with no GIL and the performance improvements that are possible there. Lots of potential. I'm certainly looking forward to it. Guys, thanks so much for coming on the show this week.
Thanks for having us.
Yeah, thanks for having us. It's been a pleasure.
Okay, so now that Python is officially, experimentally free-threaded, are you going to defenestrate the GIL? Let us know in Zulip. Yes, the changelog community's conversations are now happening in Zulip. Join today by signing up at changelog.com/community. If you've already signed up, but you want your Zulip invite, just sign in and click on send me a Zulip invite. You'll see it. Of course, it's totally free and a totally cool place to hang out and discuss. Let's do one more big thanks to our sponsors of this episode, Sentry. We love Sentry. You might too. Use code changelog, save $100. Fly.io, the home of changelog.com. Ship something in 5 minutes or less. Learn how at fly.io. And of course, to coder.com and Unblocked. Please support our sponsors. They support us. And thank you, of course, to the GOAT. Breakmaster Cylinder is the greatest beat freak of all times. Finally, thank you for listening to our shows. We truly appreciate you spending time with us each week. That is all for now. But on Friday, we are talking about developer happiness and unhappiness and productivity, or lack thereof, with our friend Abhinoda from DX. That is a fun one, so stay tuned. That's all for now, but we'll talk to you again on Friday.